Hello and welcome. My name is Alexander Moreira with AlphaStar Academy, and today we're going to be discussing the problem making mexes from the February 2025 USACO Bronze Contest. In this problem, we are given a list of n values between 0 and n. For each value I, again between 0 and n, our goal is to determine the minimum number of changes we have to make to the array to ensure that I is the smallest value that does not appear in the list. So working with a definition like this or a summary like this can be quite confusing until we take a look at an example. So suppose we were given this list of 8 numbers. So we have 3 copies of 1, 4 copies of 2, and 1 copy of 4. And for every number between 0 and 8, we want to work out what are the minimum number of changes I need to make in order to ensure that that value is the minimum number that does not appear. So starting off with 0 here, we don't have to make any changes to the array because 0 is already the smallest non-negative integer that does not appear in the array. So 0 we get for free and we don't need any changes. How about 1? To make 1 the smallest number that doesn't appear in the array, we at least have to remove all copies of 1 in the array. Otherwise, it will appear in the array and it won't satisfy our definition here. So at the very least, we have to remove all copies of 1. In addition, we have to make sure that every number smaller than 1, namely 0, appears in the array. So one transformation we could make is we could try to replace all of the 1s with 0s, and this will require 3 changes. So we remove all of the 1s while simultaneously ensuring that all numbers smaller than 1 appear in the array. So to satisfy this definition for 1, we would need to make 3 changes. If instead we wanted to make 2 the smallest number that didn't appear, well, there are 4 copies of 2. So once again, we're going to have to at least make 4 changes to the array. We're going to have to remove all of those copies of 2, and we need to make sure that every number smaller than 2 appears in the array. So 1 already appears in the array, so we don't need to add any 1s, but 0 doesn't appear in the array. So what we could do is we could transform all of the 0s into, or all of the 2s into 0s, and that would require 4 changes. Great. So we can do it for 1, we can do it for 2. How about 3? Well, you'll notice that 3 already doesn't appear in the list. So all we need to do is ensure that there are no numbers smaller than 3 that don't appear. So here we can see that 2 appears, so that's good. We can see that 1 appears, so that's good, but 0 doesn't appear. So I can just take any number in the list, say I could take this 4, and I could transform this into a 0, so that now 0, 1, and 2 all appear in the list. So I just need 1 change to make 3 the smallest value that doesn't appear. Then going on to 4, how many changes do we need to make? Well, there are 2 missing numbers smaller than 4, namely 0 and 3. And there's a copy of 4 that we need to get rid of. So this might seem like there are 3 operations needed. 1 operation to get rid of the copy of 4, and 2 operations to add a 0 and a 3. The good news is we can overlap some of those operations. So while I'm removing this 4, I can turn it into a 3 to make a 3 appear in the array. So I only need 1 more operation to transform another number into the 0. So we get 0, 1, 2, and 3 all present in the array. So for 4, we only need to make 2 changes. And what this example demonstrates is the following key observation. For each value I, the result depends on exactly 2 factors: the number of copies of I in the list, because all of these need to be removed, and the number of values below I which do not appear. because all of these must be created. So for a given value of I, our answer is simply the maximum of these two values. So in our program, we are going to want to be able to quickly determine how many copies of I are there and how many numbers below I do not appear in the original list. And if we can do that quickly, we have solved the problem. In terms of determining the number of copies in the list, we can just pre-compute a frequency array which stores the number of copies of every single number from 0 to n. To determine the number of values below I which do not appear, as we're looping through the different numbers, we can just keep a running count of all of the numbers we don't see. So with this key observation, we're ready to jump into the code. We're going to begin by reading in the input. It just consists of two things, the value n and then a list of n numbers. So we're going to store that as a length n array. And now we're ready to pre-compute the frequency of each number. So because I want to be able to know the frequency of the numbers between 0 and n, I'm going to create a frequency array with n plus 1 slots. One slot for each number. The reason why it's n plus 1 instead of n is because I'm also including the value 0. And then to pre-compute that frequency array, all I have to do is loop over the n elements in my array and increase the index of each element by 1. So if I see a 3, I'll increase the 3 count by 1. If I see a 4, I'll increase the 4 count by 1. If I see another 3, then I'll increase the 3 count again. And at the end here, frequency will just store the count of each element in the array. Then I'm ready to begin looping over and answering the question for each value of I. And while I do this, I'm going to store this variable count, which simply stores the number of numbers below I that are not present in the array A. So I'm going to loop I from 0 to n, and I'm going to print out the maximum of these two values. So this is just the frequency, the number of occurrences of the current value of I in the list, and count, which is the number of values below I which do not appear in the list. Then, after I've printed out my value, I simply have to check, is the frequency I equal to 0? If this is true, that means I does not appear in the list, and therefore I should increase the count by 1. And this completes the entire program. So thanks so much for watching the video, and I'll see you in the next one. Bye-bye.